Alright guys, so now we're going to be looking at the interquartile range and the semi-interquartile range. And it says a quartile by definition is one of the three values that divide an ordered set of data into four equal parts. The first is the lower quartile, which is Q1, and Q1 is the value in which 1/4 of the data lies. The second or middle quartile is Q2, and the value below which 1/2 of the data lies. And this quartile we know as the median, which is Q2 is equal to the median. And the third or upper quartile, Q3, is the value below which 3/4 of the data lies. And it says the interquartile range, IQR, is equal to Q3 minus Q1, and the semi-interquartile range, SIQR, is equal to Q3 minus Q1 divided by 2, right? So the interquartile range is Q3 minus Q1, and the semi-interquartile range is Q3 minus Q1 over 2, which is the same thing as the interquartile range over 2, right? So pretty simple, guys. And let's do an example. So we're going to leave these formulas here, and then we're going to do an example up the top. So just give me one moment while I clear the screen, okay? Alright guys, so now we're going to look at a little example. It says a set of data is placed in ascending order as follows, and we have 19, 12, 10, 8, 6, 5, 3, 2, 1, and it says find the IQR and the SIQR, okay? So the first thing we need to do is we actually need to find the Q1, and we need to find Q2 and Q3. So we can see here that it's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, right? So it's 9 digits. So because it's 9 digits, then the one directly in the middle, this 6 would be Q2, and there are 4 numbers below it and 4 numbers above it. So clearly that's Q2, which is the median. Now the halfway point where everything which is 1/4 beneath that point, it would clearly be the average between 3 and 2, because we have 4 numbers here, 1, 2, 3, 4, and to find the quarter point, it would be basically between these two numbers. So you'd end up with 3 plus 2 over 2, and you're going to end up with 2.5. So this 2.5 Q1 is actually equal to 2.5. And we're actually going to do the same for these numbers here. It's 4 numbers, but to find the 3/4, the three-quarter point, it's actually equal to 12 plus 10 over 2, which is actually equal to 11. So therefore Q3 is equal to 11. So since we have Q1 is equal to 2.5, Q2 is equal to 6, and Q3 is equal to 11, then we can find the IQR easily. The interquartile range is equal to Q3 minus Q1, so that's equal to 11 minus 2.5, and this should give us 8.5. Cool. And the semi-interquartile range, this is equal to Q3 minus Q1 divided by 2. So this would end up giving us 8.5, which is the interquartile range, over 2. And we should actually get 4.25 as the answer here. All right, guys. So we found the inter and semi-interquartile range. And right, so now we're totally good. So it's really easy to find them, guys. The main thing is to just make sure that you find the median, you find Q1, which is the quarter point, the point at which a quarter of the data lies below that point, and Q3, which is the 3/4 point, that's the point where which 3/4 of the data lie below that point. All right. So this was with raw data, guys. So we're gonna actually move on to group data with the same topic. Okay. All right, guys. So we're gonna be looking at the interquartile range and semi-interquartile range with ungroup data. And it says when the observations in a set of data are given as a frequency distribution, meaning the data is ungrouped, then the median Q2 is equal to half the n plus 1th rank. The upper quartile Q3 is equal to 3/4 of the n plus 1th rank, and the lower quartile Q1 is equal to 1/4 of the n plus 1th rank. So this is really important, guys, and as usual they usually give you a table, and in this table they will have two sections, right? One is usually the weight, and one is usually the number of persons who have that weight. And in this case we actually have to add two tables to it, the intervals and the cumulative frequency. So we usually end up having four tables, and these four tables we use to solve the problem, right? So I'm actually going to go right into our question now with this example. So I'm just going to clear the screen and I'm going to leave these formulas here so that we can solve the question. Okay, guys? Alright, guys, so let's look at this question now. It says the weight of 100 pupils is shown below in the table provided. Determine for the distribution given its lower quartile, its upper quartile, the interquartile range, and the semi-interquartile range. Okay? Alright, so we have this table, guys. You always get the table with only the weight and the number of pupils. You don't usually get the intervals and the cumulative frequency. And for the intervals and the cumulative frequency, you have to put that in. So we're going to put in the intervals. It's always less than or equal to 51. So it's less than or equal to whatever the weight is. So the next one is less than or equal to 52, less than or equal to 53, less than or equal to 54, less than or equal to 55, less than or equal to 56, less than or equal to 57, less than or equal to 58, less than or equal to 59, and less than or equal to 60. Okay? And for the cumulative frequency, guys, you actually add up by the number of pupils. So the first one you're gonna get, the first one you actually should get is 7 here, then 7 plus 8, 7 plus this 8 would give us 15, then 15 plus this 10 would give us 25, 25 plus 12 would actually give us 37, 37 plus 13 would give us 50, 50 plus 15 would give us 65, 65 plus 12 would actually give us 77, 77 plus 9, right, 77 plus 9 would give us 86, then 86 plus 8 would give us 94, and 94 plus 6 would give us 100. Alright, guys, and that's how you find the intervals and the cumulative frequency, and you need these to answer the questions here. So the first one says determine its lower quartile, right? So we know that from the formula here, the lower quartile, Q1, is equal to 1 over 4 times the n plus 1th rank. Cool? And in this case, n is actually equal to 100. The sum of the frequencies at the end is equal to n. So Q1 is actually equal to 1 over 4 times 100 plus 1th rank, which would be equal to 1 over 4 times 101, which would give us the 25th 0.25th rank. Now, this means that it's between, this assumes it is between the 25th and the 26th rank. And the 25th rank is right here. So in this case, it's less than or equal to 53. And the 26th rank is actually in this region, it's actually included in the 54th rank. So what we actually have to do for Q1, guys, it's actually equal to the 53rd plus the 54th, and we have to divide it by 2, and we end up with 53.5 kilograms as Q1. Alright, guys. So great. So let's move on to its upper quartile, which is Q3. So I need to shorten things, guys. It's kind of really not enough space here. So I'm gonna actually get the 3/4 of 101 of the 101th rank, and I'm gonna end up with this 75th rank. So 75.75, if you look on the diagram, you'd see that the 75.75 is actually matching between 65 and 77, so it's actually the 57th rank. So Q3 is equal to 57 kilograms. Cool. All right. So okay. So once we have Q1 and Q3, then we can calculate the interquartile range. So for part 3, which is the interquartile range, then to find the IQR, it's equal to Q3 minus Q1, right? So you're gonna end up with 57 minus 53.5, and the answer is actually 3.5 kilograms. Let me just move that. Right, so the answer, let's put the answer up here. The answer for this is 3.5 kilograms. And the semi-interquartile range, we already know, guys, that the semi-interquartile range, SIQR, is equal to the interquartile range divided by 2. So it would be 3.5 divided by 2. And the answer would be 1.75 kilograms. All right, guys. So the most important thing, guys, is these formulas here. Once you can use these formulas and you distinct where the problem is, in this case it's between the 25th and the 26th. You look on the problem and say, okay, based on the cumulative frequency, the 25th matches the 53rd, but the 26th, which is greater than the 53, is between the 54th kilogram region. So we end up with 53 plus 54 divided by 2 for that answer. That's the first question. For the second one, it's actually the 75.75th rank, which would be actually the 75th and the 76th rank. But if you look at the 75th and 76th, it's still within the 57th rank here. So you'd end up with 57 kilograms, and in order to find the IQR, the interquartile range, it's Q3 minus Q1, and to find the semi-interquartile range, it's just a half of the Q3 minus Q1, which would give us 1.75 kilograms. So not too hard, guys, and this is it. This is pretty much the end of the IQR and the semi-interquartile range. And we're going to move on now, guys. We're going to move on to theoretical probability. Okay, guys? That's it. And I'll see you in the next lecture. And remember to do your best, and God will do the rest.